Alright, we're going to take a look at alternating series here. And an alternating series is simply a series that has alternating signs: addition, subtraction. There are two ways that this can look. You can have a sum from n equals 1 to infinity of negative 1 to the n times a to the n. Or you can have the sum from n equals 1 to infinity of negative 1 to the n plus 1 times a to the n. And what that does is, on our first one, all of the odd terms will be negative, and on the second one, all of the odd terms will be positive, and the opposite for the even terms. Just to show you, if you put an odd number in here, say 5 plus 1 would give you 6, and negative 1 to the 6th power is positive, to give you a positive number. Alright, now with alternating series, there are two conditions that need to be met in order for you to have convergence. So, the first one should look very familiar. If the limit as n approaches infinity of just a sub n, so not the positive or negative part, that has to equal 0. Hopefully that looks familiar. We've seen that a lot. Definitely always a condition for you to converge. The second condition is that a sub n plus 1 has to be less than or equal to a sub n. This is what you usually have to prove. This is a term. The next term in your series always has to be smaller than the term in front of it. A sub 5 always has to be greater than or equal to a sub 6. So the terms have to be decreasing or equal to in order for this series to converge. So two quick examples of that for just some made up series here. If you have something like 1½ plus 1 1/3 minus, oops, I think that first term should be negative to actually alternate here, minus 1 1/3 plus 1 1/4 minus 1 1/5. Hopefully you get the picture there. So this series, each term as you go down does get smaller. So this satisfies condition number 2. That one is good. Each successive term is less than or equal to the one before it. However, this does not satisfy condition number 1, because as n approaches infinity, as you go out all the way, you'll be getting closer and closer to 1, not what we need, 0. So this one fails condition number 1. This does not converge. Alright. Another one that we can take a look at, this one's a little more complicated. This is actually two series combined. So we're going to start with 1/2 minus 1/2 plus 1/3 minus 1/4 plus 1/4 minus 1/8 plus 1/5 minus 1/16. Alright, now in case you don't see the pattern there, this is a little harder to see. This is two series put together. The first one, 1/2, 1/3, 1/4, 1/5. So hopefully you can guess that the next one is going to be 1/6. Okay, that is one series put together with another series, 1/2, 1/4, 1/8, 1/16. So that this one right here would have been 1/32. You can see how the pattern is there. Let's see, the yellow one is a geometric, while the red one is the harmonic series. So that series is kind of weird, but at least it demonstrates something pretty good for us. This one satisfies number 1, condition number 1. As n goes to infinity, these numbers will eventually get closer and closer to 0. But this one fails condition number 2. Right here is a great example of that. 1/5 is much bigger than 1/8. So it fails condition number 2 because the next term is bigger, not smaller. So those are just kind of two examples. Let's work through some more specific ones. We're going to go through the two in your book. Let me scroll down here. So let's see, if we're given the series sum from n equals 1 to infinity of -1 to the n plus 1 times 1/n. First off, your goal is always to sort of write your series this way. That way you can clearly see a sub n, and then here is your negative positive multiplier. You kind of want to separate those. That way you can only look at this. First, are our two conditions met? The first one is pretty easy. The limit as n approaches infinity of 1/n certainly does equal 0. So that condition is met. Is the second condition met? Is a sub n plus 1 always going to be less than or equal to a sub n? Alright, well here we have to do a little algebra. Sometimes this can be quite tricky. Let's first take a look at the nth term. The nth term is when you plug in n. So that is going to be 1/n. And then if we plug in n plus 1, we will get 1/. If you plug in n plus 1 into that, you'll get n plus 1. So we have to think, is 1/n plus 1 always less than or equal to 1/n? That is true. Okay? That is always going to be true for positive values of n. So we have second condition and the first condition. This series converges, which hopefully that's actually somewhat surprising maybe, because we've often looked at the series of 1/n. This one diverges. So 1/1 plus 1/2 plus 1/3 plus 1/4 diverges. But if you alternate the signs, minus 1/4, if you alternate the signs that way, now it will converge. I think that's kind of cool. Hopefully you do too. Alright, let's take a look at example number 2. This one, sadly, is a little more complicated and less satisfying, at least at first. So we're going to take a look at the sum as n equals 1 to infinity of n over, what do we have here? -2 to the n minus 1. Much more complicated here. So let's see. First, I think we're going to take a look at condition number 2. It looks like the book looks at condition number 2, and they have this weird first statement right here. They just kind of pull this out of the hat. Okay, and that's kind of what they do. They sort of just pull this out of the hat. Then their next step is 2 to the n minus 1 over 2 to the n is less than or equal to n over n plus 1. Alright, now why did they do that step? Well, we need to compare a sub n with a sub n plus 1. And that's sort of what they're starting to do right here. Alright, that is what they're eventually going to be doing, at least. That's what it looks like. Now, why did the 1/2 turn into 2 to the n minus 1 over 2 to the n? Well, this fraction is equal to 1/2. It's always going to equal 1/2, no matter what n is. Try it out. Plug in a number. If we have n equal to 5, now let's make a smaller number. Let's go n equal to 3. So we're going to have 2 to the 3 minus 1 over 2 to the 3, which is 4 over 8, which is 1/2. So that's some, I won't say simple algebra, but that is just algebra. Alright, what's their next step here? Their next step looks like they multiply n plus 1 to both sides. Alright, so that goes away. And do they multiply? They also multiply 2 to the n to both sides, don't they? So they're moving the denominators, they're basically cross-multiplying on both sides. Alright. So on the left, we've got 2 to the n minus 1. They put it in front. Times n plus 1 is less than or equal to n times 2 to the n. Alright. Next thing they do here. Oh, do they flip both of them? Let's see, they have that still. Oh no, now they divide both sides. They get a new color there. They divide both sides by 2 to the n minus 1, and they divide by 2 to the n. So far, so good. So I do that to both sides. I know I didn't write it to both sides, but you get the picture there, hopefully. So you'll get n plus 1 over 2 to the n is less than or equal to, and on this side we're going to have n over 2 to the n minus 1. And they're saying that proves it for us, because it looks like, is this not a sub n plus 1, and this is a sub n, it looks like? It is, look at that. That did work out. A sub n plus 1, if you plug n plus 1 into our formula, that is what you get. And if you plug in n, that looks like that's also what you get. Where did the negative go though? 2 to the n minus 1. I'll have to look at that. I'm not sure why we don't have to have negatives down here. I'm guessing they sort of cancel out a little bit somewhere, or they're just not important enough to look at that a little bit more. But they definitely started at somewhere slightly odd, manipulated everything to get down to a sub n and a sub n plus 1. It's still a true statement, and so we are confirming condition number 2, and so we just need to do condition number 1, which looks like they use L'Hopital's rule. So does the limit, I'll do it way over here, as n approaches infinity of n over negative 2, whoa, my computer is dying right now. I think I may have to leave L'Hopital's rule to you. They walk through that decently. Take the derivative of the top and the derivative of the bottom. My computer is lagging too much. Sorry.